So let's rewrite the invariant interval d tau squared, the differential version, minus dx bar squared. And let's try to write this in terms of times, tau and t bar. So the clock, so there's a clock that from one perspective measures time tau, ticks off time d tau, infinitesimal intervals of time d tau, and that clock is stationary with respect to the observer that measures ticks d tau. From the perspective of the observer, such that the clock is moving with the speed v, what we have is that the clock has moved an infinitesimal distance in the x direction, dx bar, given by the speed times dt bar. So we can then square this and say dx bar squared is equal to v squared dt bar squared, and replace the dx bar squared with this. And so what we get is d tau squared equals dt bar squared minus v squared dt bar squared. And so our quantity now on the right-hand side is written in terms of only the time parameter t bar. So we notice that we can pull out the dt bar squared, and this gives us 1 minus v squared dt bar squared. And so we get a relationship between the rate at which time ticks off according to the x bar t bar observer and the observer that measures tau. So what does that look like? Well, it's dt bar with respect to d tau is equal to 1 over 1 minus v squared square root. And so if we go back to our 2 velocity, VA, which was dt bar d tau, and dx bar d tau, we can put it into a form as we had suggested we could, that involves more directly what we would refer to as a velocity. So we get, let's just leave this like this for the moment, dt bar with respect to d tau, and let's write this dx bar with respect to t bar, and therefore dt bar with respect to d tau, and this becomes, there's a dt bar over d tau, we can pull both of those out, so dt bar with respect to d tau, here we get a 1, and here we get a dx bar with respect to t bar, and so this is more directly a velocity as measured by the observer x bar t bar. And so in that sense, it's more obvious that this is a 2 velocity that generalizes to a 4 velocity. But if we look back at this relationship, the ticks dt bar are related to the proper ticks d tau by 1 over v squared square root. And of course, this is greater than d tau. So we have a fewer number of ticks T bar from the X bar T bar perspective. And this is the well-known time dilation idea.